Tonight, we're going to spend time with a neighbor, not the kind who lives across the street or down the hall, but a neighbor nonetheless, one that hangs in the night sky, quiet and patient, waiting for anyone who knows where to look. The Andromeda Galaxy. Perhaps you've seen it. Perhaps you've stood outside on a clear night, far from city lights, and noticed a faint smudge hovering near the constellation that shares its name. It doesn't sparkle like stars do. It doesn't demand attention. Instead, it sits there, almost shy, as if it knows that those who truly notice it will pause a little longer, will look a little deeper, will join a tradition of wandering that stretches back thousands of years. Andromeda is close, in cosmic terms, impossibly close, only 2.5 million light years away, a distance so vast that the photons reaching your eyes tonight began their journey before modern humans walked the earth, before we learned to speak, before we discovered fire. And yet, in the immense tapestry of the universe, Andromeda is right next door. You can see it with your own eyes. No telescope needed, just patience, darkness, and a willingness to look. That simple fact feels almost miraculous. Most galaxies are so distant, their light so faint, that they slip beneath the threshold of human vision entirely. But Andromeda, with its trillion stars, its vast spiral arms stretching 200,000 light years across, appears to us as a gentle blur, a whisper of light that says, I am here. I have always been here, and I am coming closer. Let's begin with what you might see if you venture outside tonight. Find a place away from streetlights, away from the glow of cities. Let your eyes adjust to the darkness. This takes time, perhaps 10 or 15 minutes, as your pupils widen and your retinas shift into their most sensitive mode. Look toward the constellation Cassiopeia, the distinctive W shape in the northern sky. Trace a line from there toward the square of Pegasus. Somewhere in between, off to one side, you'll find the constellation Andromeda herself, the chained princess of Greek mythology. And there, within that pattern of stars, lies the blur. Not a star, something else, something larger. At first, you might wonder if it's a trick of vision, a smudge on your glasses, a wisp of cloud. But if you use averted vision, looking slightly to the side where your eyes are more sensitive to faint light, it becomes clearer, an oval glow, dim but definitely there. That is another galaxy, an entire island universe of stars shining across the void. Rest in this image. The blur is not empty, it is full. What you're seeing, that modest patch of light, is only the core of Andromeda, the densest part where stars crowd together in the center. The full galaxy, if your eyes could gather all its light, would span a region of sky several times wider than the full moon. Its spiral arms arc outward for hundreds of thousands of light years, filled with young blue stars, glowing clouds of gas, and dark ribbons of dust. But we don't see those arms. We see only the bright heart, the ancient core where older stars gather in their billions. The rest remains invisible to our eyes, though not to our instruments, not to our understanding. This is the beauty of Andromeda. It exists in two forms: the faint blur we can meet directly with our gaze, and the vast structure we know through science, through telescopes that see in wavelengths our eyes cannot detect, through computers that count stars and measure distances, through centuries of human curiosity that have transformed a little cloud into a mapped, measured, understood neighbor. You are seeing something real and something imagined, and both are true. 2.5 million years ago, when the light you see tonight left Andromeda, Earth was a very different place. Our ancestors, early humans who would eventually give rise to Homo sapiens, were just beginning to shape stone tools with deliberate intent. Ice sheets covered much of the northern continents. Mastodons roamed, saber-toothed cats hunted. The photons that left Andromeda then have been traveling ever since, crossing the immense gulf of space at the speed of light, 300,000 kilometers every second, never slowing, never stopping. They passed through empty intergalactic space, through the outer reaches of our galaxy, through the scattered dust and gas of the Milky Way's halo, through our solar system, through Earth's atmosphere, and finally, tonight, into your eye. This is what it means to see Andromeda. You are catching ancient light. You are looking into the past. You are witnessing a galaxy as it was before your species fully emerged. Let time stretch. Let it bend. The past and present meet in this moment. But Andromeda is not static, frozen in time. Even as we see its past, it continues to evolve, to change, to move through space. And it is moving toward us. This is one of the most remarkable facts about our neighbor. While most galaxies in the universe are rushing away from us, carried by the expansion of space itself, Andromeda is coming closer. Measurements of its light show a blue shift, wavelengths compressed, not stretched, indicating motion in our direction. About 110 kilometers per second. Fast by human standards, but slow across the gulfs of space. In approximately 4 billion years, Andromeda and the Milky Way will collide. The collision will not be violent in the way we usually imagine collisions. Stars are separated by such immense distances that two stars physically striking each other will be almost impossibly rare. Instead, the galaxies will pass through one another like ghosts, their gravitational fields interacting, pulling and stretching them into new shapes. Tidal tails will form, great arcs of stars flung outward into space. The spiral arms will distort, warp, lose their elegant structure. Gas clouds will compress where they meet, igniting new waves of star formation that will light up the merger with the blue glow of young, hot stars. Over billions of years, the two galaxies will fall back together, spiraling inward, their shapes blending until finally they coalesce into a single elliptical galaxy, no longer two spirals, but one smooth, rounded system. Astronomers have already given it a name, Milkomeda, or sometimes Milkdromeda, a blend of both parents. If Earth still exists then, and it may not, as our sun will be nearing the end of its life, the night sky will be transformed. Instead of the familiar band of the Milky Way, observers will see streams of stars everywhere, arcs and ribbons and clusters scattered across the heavens. Andromeda, once a faint blur, will grow to dominate the sky, eventually filling it with light. But that is the distant future. For now, we have this, the blur, the approaching neighbor, the quiet knowledge that our cosmic destinies are already intertwined. To understand Andromeda's size is to wrestle with numbers that resist comprehension. The galaxy spans roughly 220,000 light years from edge to edge. Its mass, including the invisible dark matter that surrounds it, is perhaps 1.5 trillion times the mass of our Sun. It contains close to 1 trillion stars. 1 trillion. If you could count one star every second without pause, it would take you more than 30,000 years to finish. And by the time you did, the list would already be outdated. New stars born, old stars died. The count forever changing. Each of those stars is a sun. Many have planets. Many of those planets have moons. Within Andromeda are countless worlds, countless systems, an abundance of possibility that staggers the imagination. How many of those worlds are like Earth? How many harbor life? How many have beings looking up at their own night sky, perhaps noticing a faint blur that is our Milky Way, wondering the same questions we wonder? We don't know. We may never know. But the possibility alone is enough to transform how we see that faint patch of light. Andromeda is structured like our own galaxy, a bright central bulge where older stars cluster densely, surrounded by a flat disk that extends outward in spiral arms. These arms are not solid structures, but density waves, regions where stars and gas bunch up temporarily, like cars slowing in traffic before moving on. Within the arms, new stars are constantly being born from collapsing clouds of gas and dust. The spiral pattern itself is elegant, almost hypnotic. Two major arms wind outward from the core, traced by bright young stars, by glowing nebulae where hydrogen gas is excited by ultraviolet light, by dark lanes of dust that absorb starlight and hide what lies beyond. If we could see Andromeda in all wavelengths of light, not just the visible spectrum, but infrared, ultraviolet, X-rays, radio waves, each view would reveal different structures, different processes, different stories of the galaxy's ongoing life. In infrared light, Andromeda's dust glows warmly, revealing rings and arcs that trace past encounters with smaller galaxies that were torn apart and absorbed. In ultraviolet, the hottest, youngest stars blaze brightly, showing where star formation is most active. In X-rays, supernova remnants glow, shells of gas blown outward by dying stars. And the central black hole flickers faintly with activity. Each wavelength is a different voice telling the same story. This galaxy is alive, dynamic, constantly renewing itself through cycles of birth and death that have continued for billions of years. At Andromeda's heart lies a supermassive black hole, not just large, but enormous, roughly 100 million times the mass of our Sun. For comparison, the black hole at the center of our own Milky Way weighs only about 4 million solar masses. Andromeda's is a giant among giants. It doesn't glow. Black holes don't emit light. But its presence is revealed by the stars that orbit around it at incredible speeds, whipped into tight paths by a gravity so intense that nothing, not even light, can escape once it crosses a certain boundary. The event horizon. By measuring how fast stars move near the center, astronomers can calculate the mass that must be pulling them, and the answer points to a black hole of immense scale. Despite its size, this black hole is relatively quiet. In some galaxies, central black holes actively consume matter, heating it to millions of degrees and producing jets of energy that shine across millions of light years. Andromeda's black hole is more subdued, consuming little, content to sit in darkness, anchoring the galaxy through its gravity alone. But it will not always be quiet. When Andromeda and the Milky Way merge, their central black holes will eventually spiral toward each other and combine, creating an even larger black hole, hundreds of millions of solar masses, releasing gravitational waves that will ripple across the universe as spacetime itself shudders from the merger. Feel the enormity of this, an object so massive that space itself bends around it. Andromeda is not alone. Like our Milky Way, it is surrounded by a family of smaller satellite galaxies, dwarf companions that orbit the giant, bound by gravity. The two most prominent are M32 and M110, both visible in telescopes as small fuzzy patches near Andromeda's core. But there are dozens more, many so faint they were only discovered in recent years. Some are irregular clouds of stars, others smooth ellipticals. Each contains millions or tens of millions of stars, tiny compared to Andromeda's trillion, but still galaxies in their own right. These satellites are not permanent. Some are being slowly torn apart by Andromeda's gravity. Their stars pulled into long streams that wrap around the larger galaxy. Like ribbons, in deep images, these streams are visible as faint arcs of light. Fossil evidence of small galaxies that were consumed, absorbed, added to Andromeda's mass. The process is ongoing. Even now, some satellites are being digested, their stars scattered into Andromeda's halo. This is how large galaxies grow, by eating smaller ones. It's a violent process when described, yet it unfolds so slowly over millions and billions of years that no single star or planet would notice the change. The galaxy simply expands, its influence spreads, its mass increases. And Andromeda, as the largest galaxy in our local group of more than 50 galaxies, has grown more than most. Feel the scale of this family. Galaxies are not solitary. They gather, influence, shape each other. To truly appreciate Andromeda's immensity, it helps to compare it to something familiar. Our Milky Way is a large galaxy by most standards, about 100 to 120,000 light years across, containing 400 billion stars. It's vast. It's home. It's the framework for everything we know about the night sky. But Andromeda is larger, nearly twice as wide, more than twice as many stars, perhaps 50% more massive when you include the dark matter halos that surround both galaxies. It is, by most measures, the heavyweight of our local group, the dominant gravitational presence. And yet, despite this difference, the two galaxies are remarkably similar. Both are spirals. Both have central bulges and extended disks. Both have satellite galaxies. Both harbor supermassive black holes. Both are forming new stars. Though the Milky Way's star formation rate is currently higher, they are siblings, variations on a theme, two expressions of how matter and gravity and time create structure on the grandest scales. When they merge, they will blend their similarities and their differences into something new. A galaxy that carries the memory of both, but looks like neither. Human beings have been noticing Andromeda for a very long time. In the year 964, the Persian astronomer Abdurrahman al-Sufi wrote about a little cloud in his book of fixed stars, the first recorded mention we have. But surely people saw it before that. Ancient Greeks mapped the constellation. Indigenous cultures across the world watched the stars with care, weaving them into stories and navigation. For most of history, For most of history, though, Andromeda remained a mystery, a faint patch of light, catalogued but not understood. It wasn't until the 1920s that Edwin Hubble, using the largest telescope of his time, identified individual stars within it and measured their distance. That discovery changed everything. Suddenly, Andromeda wasn't a cloud within our galaxy. It was a galaxy of its own, millions of light years away. The universe, overnight, became vastly larger than anyone had imagined. The Milky Way was not the cosmos. It was one galaxy among countless others. That moment when humanity realized we live in a universe filled with galaxies is one of the great expansions of perspective in our history. And Andromeda, that faint blur visible to the naked eye, was the key that unlocked it. Feel the weight of discovery. What we see has always been there, but what we understand changes everything. Now, with modern telescopes, we see Andromeda in stunning detail. The Hubble Space Telescope has created images so detailed that individual stars can be resolved, millions of them, each a point of light. In 2015, a mosaic of Andromeda was released, containing 1.5 billion pixels, one of the largest astronomical photographs ever made. You can zoom in into that image endlessly, finding clusters and clouds and lanes of dust, each region filled with stars beyond counting. But even with all this technology, even with all this data, there is something irreplaceable about seeing Andromeda with your own eyes. A photograph shows you details, but seeing it yourself creates connection. The photons entering your eyes traveled for millions of years to reach you. They are real. They are here. They are ending their journey in this moment, in your awareness. The experience, standing under the stars, finding that faint blur, knowing what it is, remains as profound today as it was for any ancient observer who noticed it without understanding. Perhaps more so, because now we know. Now we carry the story of what that blur contains. To think about Andromeda is to think about scale in ways that stretch beyond our usual reference points. Human concerns operate on human scales. Meters, kilometers, years, decades. We plan for weeks ahead, maybe months, occasionally a lifetime. But galaxies operate on scales of millions and billions of years, of distances measured in light years, that number in the hundreds of thousands. To place ourselves against that scale can feel overwhelming. Our lives, our planet, even our entire solar system shrinks to almost nothing when measured against Andromeda. 1 trillion stars renders our sun ordinary. Millions of light years make Earth invisible. But smallness is not the same as insignificance. We are small, yes, but we are also aware. We can perceive the vastness, we can measure it, understand it, contemplate it. No other species we know has done this. The galaxy is immense, but our minds can reach into that immensity, tracing its contours, asking questions, building understanding. We are made of the same atoms as those stars, the carbon in our bodies, the iron in our blood, all forged in stellar cores and scattered across space by supernovae. We are not separate from the vastness. We are expressions of it. The universe turned conscious, looking back at itself. You are not outside the cosmos. You are part of it. There is something deeply calming about contemplating Andromeda as you prepare for rest. The galaxy has been there every night of your life, whether you noticed it or not. It was there before you were born, when you were born. It will be there long after you're gone. Its stars will continue to shine. Its spiral arms will continue to turn. Its journey toward the Milky Way will continue inexorably. That continuity, that vast patience existence, puts our own brief worries into perspective. The things that trouble us, the anxieties that keep us awake, feel immediate and pressing. And they are real, they matter. But against the billion-year dance of galaxies, they are also fleeting, temporary, part of the small-scale rhythms of human life that unfold within the larger rhythms of the cosmos. Knowing this doesn't erase our concerns, but it can soften them. It can remind us that we are held within something larger, something that continues regardless of our individual struggles. There is comfort in that, a kind of peace that comes from recognizing our place.